Hello and good morning, good afternoon, good evening, wherever you are in mind, body, and spirit. Happy Thursday. Welcome to our third webinar on milling matters, our third of 3 webinars. So this is the last webinar that we will be having. Thank you so much for joining us. Real quick about live captions. Again, for those who have joined us with previous webinars, you are familiar with this. For those who are new, let me walk you through this. The language of our presentation is going to be in English, but you can change the captions that are on the bottom of the screen to your local language. You can do that by going up to the top and changing the live captions, or you can go down to the bottom and change the captions in the settings down there. Once again, you can change this to your local language. Please do not change the spoken language at all. Please do not change the spoken language. And with that, without further ado, let me carry on and welcome you once again to Milling Matters. This is our third of 3 webinars this one is about face milling that will impact your productivity and profitability. Fabulous and wonderful. And let's start with safety first. Who's important? You're important. So please be aware of your surroundings, be aware of where you are. And this as well is a safe zone. So feel comfortable to ask questions and engage with our presenters. And to that point, let me show you how you can ask questions and engage with our presenters. So up at the top of the screen is a Q&A where you can click and you can actually submit your questions throughout the presentation. The presentation will be approximately 20 minutes, and then we'll have a 5-minute Q&A at the end. And that's when we will get to your questions. Thank you so much. Once again, live captions are being used. And for those who have just joined us and missed the opening slide, you can change the live captions to be in your local language. They are currently, and they will remain in English. The language of the presentation will be in English, but you can change your local captions to be whatever language you would like to read at the bottom of the screen. Once again, do not change the spoken language. That needs to be English. This is, although we do have our presenters that have been doing the presentations throughout this 3-part series, we do have a global support team of sales, application, and product individuals out there in the field to support you. Please do engage with them. If questions were not answered during these milling webinars, we want you to feel comfortable to engage with our local team members wherever you are in the world. We do have we have Christian, who has not been able to join us on these trainings, but he is our training specialist and he's been supporting behind the scenes. We do have presenting today Eric, and Eric Gerringer is our product and applications manager. And without further ado, I'm going to hand it over to my amazing colleague Eric, and he can take over. Eric, welcome.
Thank you, Miriam. Hello, everyone. So we wanted to start off with a familiar slide. So this is the for those of you that have joined us, this is the kind of 3rd week in a row. So today we wanted to highlight face milling, and we'll go ahead and get right into it. So kind of highlight some of the differences. So when you think about what are the different types of the face milling applications that you see, and this is where it gets I'll say pretty broad when it comes to face milling, because we all do different types of face milling. It could be cubing. It could be, you may have just a plain block of steel. You may have heavy machining where you're milling forgings or something along those lines. But when you think about the different types of applications when it comes to face milling, we could be talking about high feed machining. Maybe it's flat components that you want to remove material quickly, or heavy duty operations such as forgings, or maybe your milling machine components such as ways, and then button cutters for really tough, nasty applications. You want that round insert for that extra support. And then you get into I would say more of the typical face mill applications that are truly, just typically cutters that are dedicated to face mills. When you talk about like a 45-degree lead cutter, maybe it's a 43 or a 57-degree. Those are your cutters that you will see typically in a positive type insert geometry, and also in the negative type geometry. You have double-sided when you get it more into the economy. So, and then the other thing that, I kind of, we got over there to the right, kind of out of the way a little bit, the shoulder face mills. You can actually use a shoulder mill to face mill, as we talked last week. Those are typically lighter applications, maybe even some medium type milling. But, again, the versatility from that cutter. And then you'll also see face mills develop specifically for aluminum when it comes to like automotive machining, or like if you're doing some kind of aluminum cubing or die casting. So let's talk about the different types of face mills. When it comes to face milling, as I already touched on a little bit, so there is almost an unlimited concepts of cutters, especially when it comes to indexables, that can be used for face milling. So, and one of the things that we really wanted to highlight here is to show you the variety of cutters. Even when it comes to a square shoulder, it can be used for face milling. And you'll see the different types of cutters here. So one of the things that I always try to help, kind of keep in the front of the mind, always remember, when it comes to face milling. So you got a 90-degree, and you have no chip thinning that comes from the lead of the cutter, but you will get radial chip thinning in your tool pass. We'll talk about that later. But one of the things is keep in mind, the greater the angle, as you can see, we have a 57-degree face mill, a 45-degree face mill, and then even all the way down to an 18-degree high feed mill. You're good. The further down the line you go with those angles, the more chip thinning you're going to get. So your milling opportunity or your operation is going to be more productive. So that's always a thing to keep in mind. That lower angle always equals more productivity. Now, the downside of that is you have to take into account the rigidity of the machine, the fixture, and also what you're trying to accomplish as far as surface finish and print requirements. So what are some of the requirements when we talk about face mills? And let's get into that next. So, and we already kind of started to, lean into that. So how do I pick the right milling cutter? And again, I go back to, some of the examples we talked about before in previous webinars. Is always, some of the big constants that always come to mind for me is the stability of the machine, the stability of the fixturing, and what is my workpiece? Do I have a nice heavy fixture? Do I have a good solid spindle? Is it an HSK 100 machine or an SK 50? Or am I using a BT 30 machine, or maybe an HSK 40 where the machine is not as strong or not as rigid? And then, I think a thing that we always have to remember is, what are my print requirements? What is my expectation of surface finish? What is my expectation of flatness on the part that I'm machining? That will also lead you to pick the different types of cutters. So, and then last but not least, and we'll step into this next, but the workpiece material and the machinability play a huge factor in this. So when you think about the material hardness, how my chip forms, those are the key things when you're selecting that milling cutter. So let's dive into that a little bit, and then let's talk about how the cutter pitch can make a difference and which cutter should I choose, kind of leading into this conversation. So when you think about the machinability of your components and my workpiece, fixturing setup, my spindle setup, as we've touched on in previous webinars, is when you think about like a coarse pitch cutter, these are cutters that are going to have the greatest distance between inserts in that milling concept. And then they're also going to have larger chip gullets, as you can see from the picture above, the pictures in the middle there with the coarse, medium, and fine. So when you think about materials or that are long chipping or that are really gummy or that can bind up, these are the type of cutters that would be your first choice. Uh, and then you think about, do I have a long overhang? Again, and then also in heavy machining. So if you're machining forging like a forge type steel, maybe it's a long piece of square stock. These cutters are typically what you want to use. Uh, and then also even think about your lower horsepower machines, but you need a large diameter cutter to cover your workpiece, but maybe you don't have enough horsepower. So this is a great kind of alternative to be able to use a larger diameter cutter. Okay, and then you get into the medium pitch, which is I won't say it's like a hard fast rule, but as a rule of thumb, that medium pitch cutter is kind of always your first choice for I would say for most applications. So it's going to have it's going to be that middle of the road cutter. You're always going to be safe. Your chip gullets are going to be typically enough to evacuate the chips in all types of materials. And it's like I said again, it's just going to kind of be your first choice. And then you get into the fine pitch cutters. Okay, these are going to have the most inserts that will fit into a cutter body design. And then your chip gullets, your chip spaces for your chip clearance is going to be the smallest. You're also going to have the smallest pocket wall as well. So the support for that insert. So always keep that in mind. If you're running heavier feeds, you want to keep that in mind when you're running a fine pitch cutter. Okay, and then some other things to think about is what types of materials do I run these fine pitch cutters in typically? And you're going to want those short chipping materials such as cast iron or maybe even like hardened steels or die steels, because typically you're going to want better finishes and less edge frittering as you're milling for. You don't want any of that kind of burr formation along your edges. So these cutters for those type of materials are really, really, they're high productivity boosters, and they'll also lend to giving you that better surface finish you're looking for in those type of materials. And then last but not least, when you have a lot of interruptions or intermittent cutting, a fine pitch cutter can also be a problem solver and help reduce the variation in your surface finish with a fine pitch cutter. So there again, it's going to be that kind of that best case scenario for your machining process. And then last but not least, before we move on, but again, I just want to reiterate there is no like absolute rule that these are only the only style cutter you can use. They're only kind of recommendations again. So because you will have opportunities, you could be machining maybe a softer material and still use a fine pitch cutter if you have a good enough setup. So, but the rule of thumb is typically we always like to start with that medium pitch. And then for those heavier type machining applications, we like to think about that coarse pitch cutter. Okay. But then, let's talk about some of the milling insert geometry. Excuse me. So in this slide does a really good job of highlighting, especially for face milling. And you can see here, we've got a couple of variation of inserts that go from a roughing geometry to a finishing geometry. And you'll notice, so you look at the roughing geometry at the top of the scale, it has a big R on it, okay? It's going to allow you the most feed per tooth and also typically the greatest depth of cut. Now, one of the benefits of this and how it does that is that geometry that you see highlighted in that bubble. You will see that 0.2 millimeter land on that insert. So that will actually reinforce that cutting edge. It makes it stronger. So it's like a tiny little flat right there on the edge of that. You see that 17-degree lead off the insert, that rake off the insert, but that 0.2 is it's like a tiny little flat there that reinforces that edge and makes it stronger. And then the further down the line you go, you see the FF here at the end. It's going to be the lowest feed per revolution, but also the lowest depth of cut. This is a geometry, and notice there's no land, it's just a sharp edge. So that type of geometry is what you're going to want to use for finishing to get those better surface finishes. It's going to be sharper. It's going to cut your chip in a much smoother cutting action. And again, you're going to get that surface for that really, really nice surface finish. Okay. And then, so how can the selected milling insert make a difference? You want to advance to the next slide for me, Miriam? Thank you. So when we talk about the milling insert grades, you almost open Pandora's box. So, and then, because then once you start talking about grades and you start talking about coatings, you get into the PVD coatings, which are a lighter coating, a thinner coating, and then you get into the CVD coatings, which is the chemical type coatings, which is a heavier, thicker coating. Now, those type of coatings, if you're looking for higher productivity, you think about CVD coatings. You're going to run higher surface footages. You think about PVD coatings, they're going to be a little sharper. You're not going to get as much edge rounding, and you're going to have a thinner coating. So it's not going to stand up to the heat as much as a CVD would. But the advantage of the PVD, it will help you in more unstable conditions, where a CVD sometimes it has to be a little more rigid setup. So another thing to really highlight here, and this is a typical rule in the industry. Again, it's not hard and fast. Most manufacturers follow it. We follow it. When you look at your grade, so you will see an M for milling, and that's not typical to everybody. But what I really wanted to highlight was the last two digits. So you see here in the example, we chose 8310, which is one of our milling grades. But those last two digits represent the hardness of the grade. So the lower the number, the harder it is. The higher the number, the softer it is, the more tough the grade is. So if that number, so 8310 will stand up to higher speeds, 8340 would stand up to lower speeds, but much heavier roughing conditions, maybe even heavy interruptions or forged skin or the components moving around a little bit and the fixturing on you, you would want to lean more towards that. If you're running higher speeds and you have more rigidity, you could lean more towards the 8310 grade to that 10 series. It's going to give you better tool life. So I really wanted to highlight that this morning, and this could be a whole webinar amongst itself, but I really just wanted to kind of pick out those couple points. Hopefully it will generate some thoughts in your mind as well. So, and then next, let's talk about what to consider when you're defining your tool path. And then again, so this can get fairly deep as well, but there's some examples at the bottom. One of the things that I always recommend is try to, especially face milling, the more you can arc onto your workpiece, it will reduce the vibrations. It will give you better finishes. Arc off your workpiece. Again, it will give you better finishes. And then just kind of a rule of thumb, if possible, try not to leave your workpiece when you're milling. So I know the examples we shared below, I really wanted to highlight the arcing on and off of your workpiece. But that's a little tip. If you stay on that workpiece, your finishes will be more consistent, okay? And then just one little tip that I would like to share this morning as well is when you finish face milling, sometimes you will get that, if you just pull directly off in the Z, sometimes you will get like that kind of swirly finish on the end of the cut, on the end of your cut, where you're getting that flex in your spindle. And one of the tricks that I've learned over the years, if you, instead of just pulling straight up in the Z, if you will just do like a small ramp move off the end, you will kind of clean that surface up if you have any deflection either in your workpiece or in your spindle. And I think that's important. And then also with milling, especially, it's extremely important with face milling, is always consider your radial chip thinning. And that top view up there really kind of gives you a good overview of the kind of when to take into account the radial chip thinning, when not to. So the more the cutter's engaged, you're going to have less radial chip thinning. The less it's engaged, you're going to have a lot more radial chip thinning. So don't forget about that as well. So, okay. So, and then, and of course, last but not least, I'd kind of like to leave you guys with an example of of a concept of a cutter that generates the lowest cutting forces for light duty machining. And to me, one of the great things about this type of cutter, again, the cutter is positive. So it's the cutter body itself has a positive rake and axial and radial rake. So that insert's gonna lead forward a little bit. The insert is offered in several different geometries. It again also has some positive rake on the insert as well. So this type of concept will be super free cutting. You will have low cutting forces. Your machine will be really quiet when you're using these type of cutters. And the nice thing about this concept, at least I can't, we're not the only ones that have this style of concept, but this concept for us, we offer a round insert and also an 8-sided insert. So it gives you a couple choices, because I know we all have those instances, especially when you use round inserts, it doesn't get indexed properly and maybe you lose some cutting edges. So maybe you see a little more benefit in using that 8-sided insert. But again, if you're using extremely light depths of cut with this, say like a finishing operation, maybe you do want to lean towards that round so you do get more indexes. And you could also potentially get more chip thinning if you're using those really light depths of cut. So please keep that in mind. But like I said, I just wanted to share this concept as an overview. It's one of the to me, it's one of the best concepts we have when it comes to light duty machining, or that you really want those really nice finishes. Again, and with that, I will turn it over to Miriam for questions.
Fabulous. Thank you so much, Eric. Fabulous. Wonderful. Thank you. That was wonderful. Team effort to make this happen. So thank you so much for that. So great. We do have some questions, which is wonderful. So let's get through some questions. We do have, and I also want to shout out to Pavel, who is responding to some questions as they're being asked as well. So kudos to you. Thank you so much. He's our team member. Yep. So let's start first with which geometry would you recommend as first choice for a common face milling application?
Okay, that's a good question, and I didn't even touch on the medium geometry. But typically, it depends on the application, but just kind of, if a customer called me on the phone and said, hey, it's just a general machine shop, I would typically recommend they start with that M geometry. So you're going to have a small land on the inserts typically, and it's kind of going to be that first choice. Now, if the customer calls and says, hey, I'm doing finishing operations. So again, you get into the details of it. You want to think about the application from the customer perspective. So again, I think the biggest thing for me to say is there is no like rule of thumb. This is always my first choice. It's going to be based off that application from the customer. Because if somebody from a forge shop called me and said, hey, we're going to be face milling square forged steel, I'm going to go in there with that R geometry so I can protect that insert as much as possible. So.
Great call. Thank you so much. And we also have Christian. Shout out to Christian. Hey, Christian. Welcome to the webinar. So
hi, welcome everybody. So sorry for this, but it was a really great to listen also to Eric to this webinar today. So it was a really good job. And
yeah.
enjoying also the webinar here. Great.
Yes, great to see you, Christian. Thank you so much. So let's move on to another question that we have. So when does using a CVD coded insert make sense?
Mhm.
Could you provide more details on that, Eric? Yeah.
Yeah, so I touched on this a little bit. Typically, I usually try to recommend customers use the CVD grades first because most customers want to be as productive as possible. It's going to give you a little more higher surface footage. The edge line is going to be a little bit stronger than the PVD in most applications. Of course, there's always exceptions. And the PVD insert, as I said before, it's got that thinner coating, so it's not going to stand up to the heat like that CVD is. So again, you've got to, there is like no hard, fast rule. You have to think, especially when it comes to milling, you have to think about the customer application area and what you're trying to do with it.
Got it. Solid. Fabulous. Thank you so much. We have some more questions that are coming in. And once again, shout out to Pavel, who's just like responding to him. So he's like lightning speed. He's getting to him before we can even get to him. Go team. So yeah, we actually had somebody looking for a specific cutter geometry, and Pavel he actually recommended immediately. So that's great. Real quick before we go, just a final kind of answer or question that we've had from previous webinars, and Pavel did answer this a little bit, but if you can kind of go into detail, because of our product selection, we do have the round tools and the indexable tools. So when this specifically is talking about milling indexable, so when do you actually look at milling indexable versus our round tool portfolio?
So I typically always think about indexable when cost is more of a concern, and also flexibility. And you think about the solids, whether it be carbide or even if you go back to HSS, if you're running like a manual Bridgeport or a pillar drill, for just plunging out a hole, it's all about the print requirements. If a customer comes and says, "Hey, we're peripheral milling," and I've got to have a nice flat wall, no step overs, no lines, we're going to lean towards the solids because that's going to give them what they want. But from an indexable perspective, it's going to offer you a lower cost solution when you can. So I always try to lean towards indexable, especially once you get over that 3/4 1 inch or that 20 millimeter, 25 millimeter range. When you get into the 40 millimeter and up, it really becomes advantageous to use indexable from a cost perspective.
Got it. Solid. Thank you so much, Eric. Great answer and great questions to everybody who participated. Thank you so much for your participation. And I just want to say we have posted, our colleague Martin has posted a quick link that you can give us feedback. We very much value your feedback as we continue to improve our engagement with you and the information that we share and how we can help you throughout your processes and improvements. So please do give us feedback on these webinars as well as our other types of engagements as well. And of course, if you're looking for more information, you can always contact your local sales team member or application or product support team member, or you could reach out to Christian and Eric or our virtual Pavel, who is answering questions virtually as well. You can browse our assortment online, or you can rewatch all of our webinar series, which will be posted on our website and on our social platforms shortly. So thank you so much for the time. Thank you so much to Eric, to Christian, to Martin, to Pavel, to all of our team members who supported this, and to, of course, our wonderful participants. Thank you for joining us, and we look forward to seeing you in the future as well. All the best and have a wonderful day, everyone.
Thanks, everybody. Bye-bye.
Thank you. Bye-bye.
All the best. Bye-bye.